All right, so let's see how we can use hypotenuse leg theorem in a proof. So here we're given one triangle that's split into two, right? So we actually have three triangles here. And let's see, we're given that XY, segment XY is perpendicular to segment AB. So that's given. And so, these are perpendicular here. And we don't have to write both of those, but yeah, we know that XY is perpendicular to AB. And then we know that side XA is congruent to side XB. Okay, and that's also given. So let me put that in here. XA is congruent to XB. All right. So when I know that two lines are perpendicular, that means they form right angles, right, by definition. And so we can say that angle 4 and angle 3 are right angles. And that's by definition of perpendicular. Okay, definition of perpendicular lines. And then 3, angle 4 must be congruent with angle 3. And we know that by all right angles are congruent. Okay, so then we know that these two angles are congruent here. And now we can say, okay, well, XY is shared in both triangles, right? So we can say XY is congruent with XY by the reflexive property. All right. And so now we have enough to say, since these are both right triangles, they share a hypotenuse, they share a leg, therefore they must be congruent, right? So triangle AXY must be congruent with triangle BXY. And the reason we know that is by hypotenuse leg theorem. Now looking back, I actually didn't have to say that these are congruent, right? I just need to know that they're right for, it's a right triangle. So I could have skipped step 3. All right, and so we're not done, right? That's not what we want to prove. But if I want to prove two parts that are the same, then usually I want to prove the triangles are the same first, and then we can use CP/CTC to prove that the corresponding parts are the same. Okay, and that's exactly what we're going to do. So now we can say, hey, angle 1 and angle 2 must be congruent because of CP/CTC. So angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. And there it is.